Hi, my name is Ben.
I'm Sava.
I'm Catherine.
I'm Toby, and we are team
EchoSight!
EchoSight.
All right, so as you can see in this picture right here, this is just a picture of EchoSight, which is our project, and we're going to take you through a little bit about how it does in a quick demo today. So the first question is, why did we choose EchoSight? So when deciding what project to do, we wanted to create a project that would have a real world application and impact. And when just doing brainstorming, we thought through people who live with moderate and to severe visual impairments, specifically people who use a white cane as an aid in their day-to-day. So in terms of some statistics, we saw that nearly 300 million people live with impairments, and 8% of people use a white cane, which is a pretty significant amount of people, and our project was aimed to help that. So in terms of what our project actually does, EchoSight uses various distance ranging sensors, which are LiDAR and ultrasonic, which help to relay user feedback, and which comes in the form of haptic, sound, and a physical aid. And using this, it allows visually impaired people to navigate the world in a better way.
So I'm gonna walk you through how the demonstration works. Here we have two videos. The first is on the left, my actually walking around with it. It basically functions as a white cane would, where there's the circuitry and a battery pack strapped to the main shaft of the device and all of the sensors at the bottom. The video, so the closer that I bring to life, the different sounds play, which would indicate to me that I'm approaching something. And you can see we attach the video things to the bottom to make it evidently it's unique going you can move your hands or any object closer and farther from the sensors and get the same sort of audio response. That second video also demonstrates closer to the handle. We have a haptic motor to provide vibrational feedback to someone who's using the device.
Next, we're going to talk about the circuitry. So in our device, we actually had two Arduinos, so we're going to cover them each separately. First, this is the Arduino that handles the input from the two sensors, as well as the motor control and an LED that relays information to the other Arduino. So on top, we can see we have the ultrasonic sensor just wired straight to the Arduino. On the left, we have the LED, which is connected to an analog pin on the Arduino, so we can step the voltage with different pulse width modulations. At the bottom, we have the LiDAR sensor, which uses serial data, so it's only connected to the Arduino on two ports for its data and is read serially. And on the right side, we have the motor with the battery pack underneath, demonstrating how we used a N-channel transistor to control the haptic feedback motor.
So one challenge that we discovered was that our code was, or like the Arduinos are not quick enough to run both of the applications, so like sound and the input that we're getting from both of the sensors. So we just decided to split it up a little, and we found like a pretty smooth solution. So we have like one solution that Ben just presented with the Arduino, and we have another Arduino that is running our code that is technically just like transferring our voltage data we get depending on how bright the entire and how bright the LED is, and transfers that into a frequency and a volume, so like pitch and the volume of a sound wave technically. So we have this circuit that is pretty similar to the lab that we did in the Theremin, and we had to adjust some resistances and compress it a lot, and then we have the two LEDs that technically just function as digital potentiometers, and two independent circuits that run different Arduino code, and yeah, make our entire thing work that quick and smoothly.
So in the next couple of videos just show a demonstration of these challenges.
Yeah, so first we had trouble figuring out how to get the two parts of our sensors and our output to talk to each other. So at first we got pitch dependent on voltage, but we realized that it was also dependent on the frequency that our circuit ran. So when you play the clip,
It's just dependent.
Not actual changes in the pitch, but because our sensor readings were so time consuming, it wouldn't produce actual pitch and instead produced noise. And then when we improved our code, we instead got here in that clip. So instead we had to separate it into two circuits to get a working final product.
And that's
Thank you.
EchoSight. Thank you so much.
Thank you.
I think we're over time.